Since we have a snow day today, we're going to go ahead and learn about dilations in the coordinate plane. Recall that a dilation is a non-rigid transformation in which the coordinates, usually both, but it could just be x or y, are multiplied by a number, and that number is called the scale factor. We're going to use the letter k to represent our scale factor. So the coordinate rule for dilations is xy maps kx times ky. The shorthand notation will use a D for dilations, and the subscript is going to be k. And again, k represents the scale factor. Things that you need to know about dilations: if the scale factor is larger than 1, then the dilation will be an enlargement. You can call that a stretch or an expansion. If the scale factor is between 0 and 1, then the dilation will be a reduction, which is also known as a shrink, a contraction, or a compression. The preimage and image will be similar, not congruent, as long as both the x and the y coordinate are multiplied by the scale factor. We'll talk about when only one of the coordinates is multiplied by a scale factor in just a few minutes. So let's try an example. Draw the dilation image of triangle ABC with the center of dilation at the origin and a scale factor of 4, where points A would be -2, -2, B is 1, -1, and C is 0, 2. Because the scale factor is 4, that indicates that this is going to be an enlargement because the scale factor is larger than 1. You can kind of relate it to when we talked about exponential functions. If the base was bigger than 1, then it grew, and if it was between 0 and 1, it shrank. So this is an enlargement. And you can write in words the scale factor is larger than 1, or you can just write that the absolute value of k is bigger than 4. Whoops, not 4, 1. The reason the absolute value is in there is because k can be negative, and we're going to talk about that next week. Okay, so the rule in coordinate notation would be x, y maps. And we're going to take our scale factor, which is 4, and we're going to multiply it by our x coordinates. And we're going to take our scale factor again, which is 4, and multiply it by our y coordinates. The shorthand notation would be a D with a subscript of 4. So to actually get our points, we are going to take each of our coordinates and multiply both x and y by 4. So -2, -2 is going to become -8, -8. Sorry, these numbers don't look so great. I'm writing on my iPad. 1, -1 is going to become 4, -4. And C prime will become 0, 8. And then what you're going to do is you're going to graph each of those points. So -8, -8. There's your A prime. 4, -4 is B prime. And 0, 8 is C prime. And what you'll see when you connect these is that your triangle has now expanded. What you'll notice about it is clearly triangle ABC and A prime, B prime, C prime are not congruent, but they are similar, which means angle A and angle A prime are congruent, B and B prime are congruent, C and C prime are congruent. So the triangles are the same shape, obviously, but they are different sizes. Okay, let's try a second example. Draw the dilation image of rectangle ABCD with the center of dilation at the origin and a scale factor of 1/3 with points A, B, C, and D, and you're given the points. The reason it keeps saying the center of dilation is at the origin is because that's what we're using for our center of dilation. Next year in geometry, you'll learn about dilating it with a different center. So since the scale factor is 1/3, then that means this is going to be a contraction. And again, you can write in words that it's a contraction because the scale factor is between 0 and 1, or you can use the notation the absolute value of k is between 0 and 1. I don't care either way, it doesn't really matter. Okay, so for our rule, what we're going to do is we're going to take our 1/3 and we're going to multiply it to all of the x and all of the y coordinates. So the rule will look like xy maps 1/3 x and 1/3 y. And again, that just means 1/3 times x and 1/3 times y. The shorthand notation will be a d with a subscript of 1/3. Remember that multiplying by 1/3 is really the same thing as dividing by 3. If you look at all of our coordinates, they're all divisible by 3. So we're going to take a, which is 3, 9, and we're going to divide 3 by 3, which is 1, and 9 by 3, which is 3. So a prime will be 1, 3. Then we're going to take b, 9, 9, and either multiply by 1/3 or divide by 3, so that's going to give us 3, 3. C prime will become 3, 2, because 9 divided by 3 is 3 and 6 divided by 3 is 2. And d prime will become 1, 2. So when we graph that, 1, 3, 3, 3, 3, 2. It's going to be really hard for me to graph because it's so tiny. And 1, 2 is going to be this teeny tiny little square right there. Let's see if I can even fit a prime, b prime, c prime, and d prime. So you can see that clearly that contracted or shrank. It got much, much smaller. And it's getting closer to the origin. That's why our center of dilation is the origin. Okay, so we've looked at a couple examples where you're given a figure in the scale factor and you just had to graph the image. Now let's look at where you're given the coordinates of the preimage and image, and then you needed to decide the scale factor. So we've got triangle ABC, and the coordinates were 0, 0, 0, 4, and 6, 0. And then A prime, B prime, C prime was 0, 0, 0, 2, and 3, 0. Sometimes identifying the scale factor is going to be pretty obvious, and other times you might need to do a little bit of work. But what we can see, and I probably wouldn't use A in A prime because it remained the same, but you can pick any point. So I'm just going to use B and B prime. So B started out at 0, 4, and then it became 0, 2. So what you can see is that the x-coordinate still is 0. It didn't change, but the y-coordinate went from 4 to 2. Many of you may look at that and say, well, obviously you divided by 2. If you can't look at it like that, then what you can do is you can take the y-coordinate. We started with 4. We multiplied by some scale factor, so we're just going to use k, and that equals 2. And to solve that, you would need to divide both sides by 4, and if you do reduce that fraction, you get 1/2. So the scale factor is 1/2. Okay. Now, if we look at the next example, we are starting with the same preimage, ABC, same coordinates, and now A prime, B prime, C prime, we've got 0, 0 for A prime, B prime is 0, 10, and C prime is 15, 0. Again, when comparing, I'm not going to look at A because there's no difference in A, but let's take a look at, we'll use C this time. C was 6, 0, and now it's 15, 0. I can't compare the y coordinates because there's no change, but I did start with 6. I multiplied by some scale factor, again, we're just going to call it k, and it gave us 15. To solve this, divide both sides by 6. Reduce your fraction. 15 over 6, those are both divisible by 3, so that'll be 5 over 2. We usually leave it as a fraction. Technically, that's the same as 2.5, but I'm just going to leave it as 5 over 2. All right, so this next example is very similar to the two examples that we just did. The only difference is we're given a visual instead of the actual coordinates. So the first thing I would do would be to identify the coordinates of your preimage and identify the coordinates of your image. So if we look at A, we've got -2, -2. B is -1, 2. And C is 2, 1. A prime is -4, -4. B prime is -2, 4. And C prime is 4, 2. Pay really close attention to your preimage and image, because if you get those backwards, then you will get whether it's an enlargement or reduction backwards. Our image clearly got larger, so this is an enlargement. We need to identify the scale factor so that we can write the rule. Again, several of you may be able to just look at this and see, well, obviously all the coordinates doubled, so the scale factor is 2. If you can't see it, pick any point. I'm just going to use A, and I'm going to compare the x-coordinate. So I started with -2, I multiplied by a scale factor, and it gave me -4. I'm comparing these two coordinates right here. If I divide both sides by -2, I get that the scale factor is 2. Again, that's useful if you cannot look at it and tell what the scale factor is, but most of you, I'm guessing, could look and see that you doubled. So to write the rule, again, in coordinate notation, always the same beginning, xy maps. We took our x-coordinates and multiplied by 2. We took our y-coordinates and multiplied by 2. The shorthand rule would be d sub 2. All right, so number 6, again, same exact thing as what we did in number 5. A little bit different. If we look at the preimage is the blue figure, A, B, C, D, because there's no primes, and then our image is A prime, B prime, C prime, D prime, which is the red image. Hopefully you can see that that is a reduction. That tells us that we are going to have a scale factor between 0 and 1. So let's identify the coordinates. A is -8, -4. B is -8, 8. C is 0, 8. D is 0, -4. A prime is -2, -1. B prime is -2, 2. C prime is 0, 2. And D prime 0, -1. The biggest mistake that I see students make is they treat it as it is an enlargement instead of a reduction. So hopefully looking at the coordinates, if we compare the x-coordinates, all of our x-coordinates were divided by 4, and so were all of our y-coordinates, which means the scale factor is 1/4. If you're not good with fractions, you may want to pick an x-coordinate, so I'm going to use the x-coordinate of A, which is -8. I know I multiplied by some scale factor, and when I did, that gave me the x-coordinate of A prime, which is -2. If I divide both sides by -8, reduce that fraction, I will get my scale factor as 1/4. So when writing the rule in coordinate notation, as always, xy maps, we took 1/4 and multiplied it by our x-coordinates. We took 1/4 and multiplied it by all of our y-coordinates. The shorthand notation, d sub 1/4. If you look at all of the dilations that we've done so far, the image and the preimage, although they did not remain the same size, they did remain the same shape. So now we're going to take a look at dilations in which you are not going to have similar image and preimage. Everything so far has been similar, not congruent, but just similar. So now if we look at we're going to focus on just multiplying one of the coordinates by some scale factor. Okay, so the first one is we can horizontally stretch or shrink it. Remember, horizontal will be left and right, which is going to affect the x. So the image will not get any taller, but it'll get either wider or it'll get narrower. The rule in coordinate notation is xy maps ax comma y. You can use any variable. It doesn't have to be a. If you want to stick with k, you can do that. It's just there's going to be some number there, and only the x coordinates are going to get multiplied by that number. Okay, so that's the first thing under important to know. The other thing is that the preimage and the image will not be congruent. They will also not be similar. Okay, for a vertical stretch or shrink, you're only going to multiply the y coordinate by that scale factor. So what that's going to do is it's not going to change the x coordinate. So it's only going to change the y coordinate. So the y coordinate is either going to get, the shape will either get taller or shorter. Again, same thing for horizontal stretches and shrinks. They are not congruent and they are not similar. All right, let's look at this example. We're going to graph square math. I've already graphed it for you and written down all the given coordinates. Here we're going to use the rule xy maps 3x comma y. Notice that the 3 is only being multiplied to the x coordinates and not the y coordinates. Okay, so what that's going to do for point M, which is negative 3, 7, we're going to multiply the x coordinate, which is negative 3 times 3. So that's going to give us negative 9. And then the 7 is going to remain the exact same. A, which is 1, 7, I'm going to multiply 1 by 3, so that's going to become 3, and the 7 stays the same. T is 1, 3, I'm going to multiply 1 by 3, so that's 3, the y coordinate stays the same. And H, which is negative 3, 3, I'm going to take the x coordinate, multiply it by 3, which is negative 9, and then the y coordinate remains the same. Because the 3 is only being multiplied to the x coordinate, this is still a dilation, but now it's not just a regular dilation, it's a horizontal dilation only. So we're going to write it is a horizontal dilation. This is going to stretch still. So you could say either a horizontal dilation or a horizontal stretch. I'm going to put horizontal dilation that stretches, and this is going to stretch by a factor of 3. Now the way that I knew that it stretches is because the number that's being multiplied to the x coordinates is 3, and 3 is larger than 1, so that's why it's going to stretch. And I think as soon as you graph it, you'll see that it stretches. So M prime is negative 9, 7. A prime is 3, 7. T prime is 3, 3. And H prime is negative 9, 3. And so when I graph that, hopefully you can see this is just a horizontal stretch. I graphed H kind of in the wrong spot. It gets wider, but it does not get taller at all. So we started with a square and now it's a rectangle. So hopefully that you can see definitely the shape is now different and also the size is different. So this is not congruent and it's not similar. So this would be a type of dilation where they are completely different figures. For our last example, we're going to look at trapezoid snow. How appropriate given that we are out of school for a snow day. I have already graphed the given coordinates, and we're going to use the rule xy maps x 1/2 y. Okay, notice that nothing is being done to the x coordinate, so this is going to only affect the y coordinate. So this is going to be a vertical dilation, and this is going to be a compression or a shrink. I'm just going to write the word compression, but if you'd rather do shrink, that's fine. And this is going to be by a factor of 1/2. I knew it was a compression because the number that's being multiplied is 1/2, and that's going to make everything get smaller by a factor of 1/2. So for this, all of my x coordinates are going to stay the same, so I'm just going to go ahead and write all my x coordinates in. And then all my y coordinates, I'm just going to chop in half. So 6 times 1/2, or 6 divided by 2, is 3. That's going to be the same for both of those. And then negative 8 divided by 2 is negative 4. So when I go to graph that, we've got negative 4, 3. And there's S prime. Then we've got 4, 3. We've got 10, negative 4 for O prime, and W prime, negative 10, negative 4. When I draw that, hopefully you see width-wise, it did not get fatter or skinnier, but it did get shorter. So that's why this is a vertical compression. The other thing that you may notice is although it's still a trapezoid, the angles now are completely different measures. So again, the image and the pre-image are not congruent and they're also not similar. Anytime you either horizontally or vertically affect or dilate a pre-image, you will not have similarity or congruence. I hope you guys have an awesome day today. I will see you tomorrow, and we're going to review rotations and dilations and plan to quiz on Friday.